Welcome to another edition of Coffee with Developers. I'm here with the YouTube famous Sam Witteveen. He's in Singapore, I'm in Vienna. It seems like the internet is working, so that's good. So you were one of the first machine learning Google developer experts, is that right?
That is true, yes. Back in 2017, when AI wasn't cool, right? When ML wasn't cool.
Yeah, and I mean that's an interesting thing. Like, where's I mean, I've seen so many diagrams explaining that properly, but like, where do you see the difference between like machine learning, reinforced learning, and AI? Where is the thing? What would you call AI? What would you call machine learning? Where do you draw the line?
So for me, I would say AI is a marketing term, right? Like really, AI is a marketing term. Most of what we see nowadays that people are calling AI is deep learning, right? And that's what I've been sort of working on and interested in for over 10 years. Unfortunately, AI has just become this catch-all phrase now that everyone uses for all these kind of things. Even worse, generative AI. Like, I guess it makes sense. But I get all these people adding me on LinkedIn that are like, senior generative AI vice president for some big company, and you just think, oh no, right?
I think my favorite was one person that connected with me the other day that was like chief co-pilot. And you're like, Copilot is not what it's like. I mean, I think there's a job title, random generator, by now. And a lot of people used to be like a Bitcoin expert, and within 2 days they became AI experts just on LinkedIn.
Oh, so, I know them so well, Chris. I see them so often.
So how do you feel? How do you stand out as somebody who knows that really? Do you just say like, let's give them the limelight? I don't care. I do my stuff anyways. Do you think that there is a benefit to the hype that we have right now, or is it mostly distracting?
I guess it's definitely a benefit in that there's a lot more, there are a lot more resources available. There's a lot of investment, all those sorts of things have gotten way better. When it is kind of nuts that when we used to, go along with research papers to the NeurIPS conference or something like that, and it wasn't a big deal. Now you go along and there's like 7,000 people or something, and that's really changed. In fact, I was in Vienna just in July for ICML, for the ICML conference, and it was definitely a different vibe. If anything, actually the vibe now probably wasn't as good because all the big labs just don't want to talk about what they're doing now. So they're not showing up at these conferences like they used to, or if they are, you go up to them and start chatting. And where in the past people wanted to share, like, this is what I'm doing and this is what we're seeing that's working and that kind of thing. The last 5 years, people are kind of like, oh yeah, I can't talk about anything. Right? It's like, what kind of coffee do you use at work? Oh, I can't talk about that. That's like secret.
Which is interesting because Google kind of takes a different approach. Like with the Gemma models, these are all open source, right? Like how open are they? Like, I mean, there's a lot of open in the ML space, but then you realize there's lots of restrictions if you read the terms and conditions, or you ask a machine learning system to read the terms and conditions for you, because we never do that. Like, what are the Google offerings that are completely open source that you can actually recommend people to take a look at?
So technically, they're not open source fully. They're what we call open weights models. So the weights are fully available and you can run it. You can do pretty much everything that you want to do with it. I think, I haven't looked at the latest license, but in the past, Google's generally been pretty permissive. They've just, it's just kind of like you can't use it for war. Maybe you can't use it for porn, that kind of thing. The big difference, though, between sort of open source and open weights is that we don't have the training code that made it, right? We don't have the data set that made it. All of those things are still controlled by Google. Now, there's two ways of looking at that. You can either look at that and say, oh, we really, need to, as a researcher, we really want everything. And of course, that would be true if you're a researcher. But for most devs, actually, it doesn't matter, right? You're not going to spend the $2 million to train the model anyway. You're not going to, probably not even going to want to store the data set that's so big, on hard disks and stuff like that. So the cool thing with like Gemma 3, the latest model that has come out, is that not only is it open weights where people can use it, there are 4 different sizes. So it actually is now really sort of focused on the developer community, so the developer community can sort of choose what they want to do. If they want to be like doing something with a big company, perhaps where they're going to build something on-prem, they want to run the model on-prem, they want to fine-tune it, they don't want anyone looking at what's going through it and stuff like that, they can go for the nice big 27B model and get something that model is as good, roughly about as good as Gemini 1.5 Pro from 6 months ago. It's kind of amazing, right? Like, this is one of the things that even I was surprised when when these models were first announced, that basically, Google has let an open model come out of their, organization, which is, on par with what they had as proprietary models 6 months ago. That's really kind of nuts. So you've got everything from that sort of like big model right down to sort of like what we call 1B models, which you can put on a phone if you wanted to train something for you wanted to make a mobile app or anything. And you've got a couple of models in between. So this is, while it's not open source in the traditional sense of like we can see all the code and we know every single thing about it, they are open in that we can use them for commercial use. We can use them for, pretty much any project we want to do.
As a reminder, like you said training data, you said weight. What is the difference between the two? Like, how does open data sets, like huge data sets, become an LLM? How do they become a model that actually we can use? What does the weighting process look like, and what does it mean?
So the simple way of sort of looking at this is that these models are basically trained to predict what we call the next token. Now, most of the time, the next token is going to be the next word. And so they're just trained on trillions of these tokens or trillions of words. And for the big model, for example, that's like 14 trillion tokens that it's trained on. It's trained with a lot of TPUs. So Google's not using GPUs for doing the training. They've got their own custom hardware for doing that. Then basically the model then learns to be able to get good at predicting the next word. This is what we call pre-training in the model. This can take quite a long time, obviously, to get through 14 trillion tokens. And then once that's done, they then basically do what we call post-training. So that's teaching the model to, rather than just keep predicting the next word, learn to sort of give us an answer in the same way that maybe a human would give it. And then with that they combine in some reinforcement learning to try and get the model to be better. But this process takes a long time. It's not something that people can just do with these big models. Really, it's only the frontier labs that are able to allocate the resources for training these sort of medium to large kind of models. The cool thing that we can do, though, is we can take those and fine tune it for our use. So if you've got your podcast here and you've got a whole YouTube channel and stuff like that, if you trained it on all of the things that you've said there, you would be able to use it for generating different things there, or you would be able to then combine it with a retrieval system for being able to find information really well and then give it back in the style of perhaps the way you've said it or one of your guests has said it.
Interesting. What's the difference between Gemma and Gemini?
Okay, so this is something where people get a little confused, and honestly, Google hasn't done a great job with the term Gemini, because there's like 6 different things probably that mean Gemini in Google. So the Gemini models are the big proprietary models that Google trains. They've just released Gemini 2.5 Pro. Is sort of like the latest and greatest of that. It started back sort of not quite a year and a half ago, but well over a year ago now, where they released the first version of Gemini. And they're basically the models that you cannot get access to the weights. It lives in Google Cloud. You want to basically use it. You ping Google Cloud, and that you ping up whatever you want to ask the model. The model will give you a response back. Gemma models are trained so that you can choose where you want to serve it. So if you want to take that model and you want to serve it in a different data center, or you want to serve it on-prem, So like a lot of the customers that I work with and stuff like that, they're interested in doing things on-prem, especially where I'm located in Singapore. A lot of data is just not allowed to leave the country. So financial data, things like that are not allowed to leave the country. So in those cases, people tend to want to, basically take these models and serve them on-prem or in their own private data center or something like that. So that's where the Gemma models come in. And also on top of that, the Gemma models are also made so that people can use like small models on phones or on Raspberry Pis, even on your sort of laptop and stuff like that. You can run one of these models 100% local, have it be able to do a lot of the things. Maybe it's not quite as good as the latest and greatest reasoning models or things like that, but it's come a long way, right? Just in a few years, we've gone from from these models not being very good unless you had a super big one, to now the small models being actually very useful, very good for a variety of different things.
How was that achieved? Is this something like a self-optimization, self-weighing kind of thing? Like, how do we get the models to be so much smaller and at the same time be as effective as the old ones? What was the learning there?
So there are a few things. One is just a lot more data, right? The just like, to give you an example, many of your people will know GPT, the GPT models, right? Or GPT-3. That was trained on 300 million tokens of data. Like I said, the latest Gemma model is trained on 14 trillion tokens of data, right? So that's an insane difference when you're sort of like, looking at that. So that's one of the things. The other thing that Gemma has actually put a lot of effort into is what we call distillation. So distillation is where they basically take a bigger model and get the smaller model to learn from the bigger model. So you're distilling a lot of the sort of learnings that are in the big model down to a smaller model. And actually all 4 of the Gemma models have used some of this distillation to actually make them so good. This is why the 4B model, right, which is actually the 4B, you could run it, you'd be pushing for a phone. As long as you got a phone with some good amount of RAM, it could run it. But certainly on your computer, you can run it quite easily. That 4B that's just come out now is as good as the 27B that came out in July. And the 27B that came out now, I mentioned before, is as good as the Gemini 1.5 Pro, which was, up until very recently, one of, Google's sort of key proprietary models.
Wow. Yeah, I mean, the good thing about these small models, I think this is also the ones that are going to be shipped with browsers. Like we had a great talk yesterday by Tom Steiner, who basically showed us what is actually in Chrome already in there with the window AI, and you got like a language conversion, language detection, and these kind of things all on device now that ships with the browser. And I guess that's one of the smaller models then that actually is built into that.
Yeah, I think they're using around about a 1B model for the Chrome, the version that's in Chrome, in Canary at the moment, that's coming out, in the future. You will see, you'll certainly see as these models get smaller, they're going to pop up everywhere. And I think, for people who are doing any sort of on-device thing, when you can basically put these models onto devices, it's suddenly, already all the Pixel phones, for example, have a version of Gemini if it's a recent Pixel phone. But I think, gradually over time, we'll see that sort of pop up all over the, thing on most devices that we have.
And I love when it becomes non-transparent, when it's just there. I mean, not transparent, just like when it helps you along. I mean, my favorite example for that, when I started talking about this in 2018 as well, like I was like, Google Photos was my favorite example. Like I can type in the German word for dog and it will find pictures of dogs in there, although I never tagged them as dogs. They just realized there's a dog in the picture and you didn't answer dog. There was no result for dog. There was no result for the German term, but like, hey, translate it to English and then do the search. So there's a lot of clever roundabout thinking in Photos itself to do these kind of things, or remove backgrounds, like take out smaller things. I think the Photos in general is in any of the mobile phones that we have these days, that we're past the stage where we care about the quality of the lenses, because 80% of the photo is post-production in machine learning anyways, isn't it?
Yeah, totally. Actually, that's another good point that you make about the one of the good things about Gemma 3 is that Gemma 3 is sort of the first version of Gemma that really is very, very strong at multilingual stuff. So it's trained on like 140 languages. So, where we've seen, competitors and stuff like that put out models that are maybe trained on English and then some of the key, Western European languages kind of thing. The Gemma models are trained on 140 different languages. They can handle most of the Asian languages, no problem. Most, languages that I haven't even heard of kind of thing are showing up in there. And that's a really good sign, because I think it's always easy for us to forget if we speak English that, oh, okay, well, these models are going to be great. And even, for the languages like the Spanish, Italian, German, those sort of things, they've always been pretty well treated in some of these models. But the fact that Google sort of realized that, okay, between Gemma 2 and Gemma 3, they doubled the amount of multilingual data, it is really a sort of conscious decision to actually make this stuff work for other places around the world. That's one of the things I think is actually really cool about Gemma 3.
Another marketing term that I see being thrown around all the time is multimodal. What does that mean? Audio, video, text, or what does it mean generating all three of them, understanding three of them? Like, what does multimodal generative AI mean to you?
Yeah, no, that's a really good question. So the Gemini models have always been multimodal, but they haven't sort of exposed it always to the to customers and users. With the Gemini 2.0 models and now the 2.5 Pro, they are exposing that. So, for example, with the 2.0 Flash, you can basically go, audio in, text in, video in, images in, and you can get out, text out, audio out, or even images out. Right. So that's pretty cool, that the fact that these models now can be used, especially where with one of the versions of the Gemini Flash is that you can use it in real time to basically have a conversation with it. It can sort of, watch a video with you and you can ask it questions, those kind of things. That just wasn't possible a couple of years ago. And one of the things that's really interesting from that is that actually makes the models smarter, right? So when we're sort of talking about like, how do we get these things to be smarter, when they can be grounded in different modalities, they actually tend to sort of get an understanding, I'll put that in inverted commas, that actually makes it sort of better than just reading it in text. So that's kind of cool to see that that's really starting to take off.
And I think it's needed in the world that we have right now, because when you get customer data, you never get structured data. You get like random PDFs, Word documents. You sometimes get a video. You sometimes get like badly scanned pictures of old documents. So I think we need to. One of the bigger things that I see AI can help us with is to clean up all that cruft that we got from customers in the past and actually turn it into more structured data. What is weird, though, is that it seems like Markdown is like the language du jour about data, and it drives me nuts because it's not even standardized.
That's true. Yeah, definitely. For the LLMs, when you're dealing with text, people tend to convert things to some form of Markdown, just because it's just quite efficient and easy to train these things. My guess is that over time we'll see these things change. Definitely, like it's only been sort of since December that some of these things were possible to do in Gemini or in any of these models. It's only a few months. We're only sort of a few months into that. This whole idea of real-time sort of stuff, where it can just take all these documents in and process it and then run a Google search on it and bring that information back and fire off to some other APIs and bring that information back. This is where these things are getting really strong. And it is kind of funny, like you point out that sort of you can imagine it wasn't that long ago before all of us were spending hours trying to build pipelines to convert all these weird kinds of data into some kind of unified system, Whereas, it's looking more and more that nowadays you just chuck it all in, right? And let the model sort of figure it out. And because it's seen enough of these things already in its training data, it does know how to figure it out. It does know how to work out, what's going on. It is really fascinating for me with the new Gemini models is that you can speak to them in different languages. And even though it may not sort of be officially supported, it's able then to, to understand, at least understand what you're saying, and then probably give you some kind of response. In a lot of languages, it can actually respond to you in your language. And often with an accent that kind of matches what you would expect, right? Not some just kind of American, fake accent. And that's just basically just giving these things so much data that they're able to sort of pick up the patterns.
Yeah, that was always the thing with Google, which cracked me up. Like, I mean, other platforms, when you're like, oh, you got like 4 GB of photo storage, and Google is like, hey, I generated an animation from your last 10 pictures for you. So how do you like that? And I made a background image and like put some music on it as well. When it comes to generating images, what always drives me nuts is that it gets the text wrong. So if I say like, create an image of a turtle on a skateboard that says hooray on top of it, you can bet your life that the first 10 pictures will have hooray written in a wrong way or even half characters. What is that flaw? Why is that?
Okay, so that actually is a thing that's just starting to change, like literally in the past few weeks. Both Google and OpenAI have released models now that are much better at text. Really, it was just a lot of it was to do with how the models were being trained. Perhaps they weren't given enough examples of text. There was no sort of loss function associated with the text, that kind of thing. But it is changing. They're definitely, not only getting better at text, but they're just getting better. Like the video models, I've just been sort of playing around with some of the new Google VO2 models recently. And it's kind of nuts that like I can basically sort of ask it to generate me a video of downtown Singapore with elephants going down the street, and it has no problem at sort of working out, how to do those things. So gradually, each of these things gets better and better at different, at different kind of modalities. So the text is definitely getting better.
Yeah, video generation is a very interesting one, because I remember, I'm the kind of person that always looks at like at like the papers on archive.org, and you see like these papers like, oh, I can now predict what car is going to drive around the corner, and like these kind of things. And it was just outstanding back then to see this paper, and it took like 6 hours to calculate that 5-second video. And now these things just come into those models and are just becoming a part of it. Like, and a lot of it came from the film industry, I guess. Like muscle augmentation was one big thing that like all superhero movies are using. Like these become just a normal thing that you as a developer can just use on your local videos as well, and that's pretty impressive. So the completely generating new videos is one thing, but cleaning up other videos and stuff. I remember a big thing was like drone footage, and then people using a model to stabilize them. That was a huge breakthrough. And I think there's a lot of these things that are just in there now, detecting the error automatically, so I don't even have to tell it how to clean it up.
Yeah, I think you hit the nail on the head there, that all of this stuff is becoming now where devs can just go and use it, right? They don't need to go and read the research papers. They don't need to go and think, okay, how am I going to code this in C++ to get it to be efficient? A lot of these things are either becoming local models that you can use on your own machine or on your own device, or they're just an API call away for doing this. And I think that's sort of like across the board, whether we're talking about, text, audio, it is really amazing now, just that, even things like transcribing audio, that used to be just such a pain, right? That even when you had a good model, it would basically be wrong about 10% of the time. And now these things are just, they not only can they transcribe it, they can do diarization, they can work out who was talking at what time, they can then, turn them into notes and summarize it and do a whole bunch of these things. So I think a lot of the, I think for devs, if you're not an ML dev and you've got no interest in sort of knowing the, what's going on behind the scenes or something, it really doesn't matter, because you can still use all these things and build really cool apps, build really cool experiences for users with this kind of stuff, just by sort of learning, the sort of basics of how to basically do some of these things without having to know how it actually works in the back end.
An interesting bit about this is also the how it connects to each other. I see a lot of these tools cropping up that you can get a transcript from an audio file or a video, and you can edit the transcript, and then it edits the video for you at the same time. And that's just bonkers if you think about it. Like, that saves so much time. Like, is it just timestamps, or how does it do that?
No, so that's how I do all my YouTube videos. Yeah, like exactly, right. And the cool thing is, like, I don't even have to bother. Like, if I say something, not only can I do that, like what you said, if I then go to the edit later on and I realize, I've called this the wrong name, or I've said, I forgot to say this one word or something like that, I can just get it in and render it in my own voice into the actual, recording.
Oh, wow.
So, so that's basically, a combination of things like timestamps with the transcript, knowing exactly each word and each syllable is at what timestamp, point. Then it becomes quite easy to be able to edit these things.
How much of your video content is generated then, rather than you really speaking it?
Very, very little, very little. No, like it's more sort of things like, if I realize at the end that I said, that I said the wrong, that I said the wrong name or something like that, then I will go in and edit it. The cool thing is, for me, I don't think it works well if I do it like, a full sentence or something, but it works nicely for a word or two where people won't realize that, okay, that one word is artificially generated. So, like where I've had things where I've talked about the model size, and I've been thinking about one model, and then I mentioned the size of that one while I'm talking about this one or something like that. So I'm not, but there are people out there that are doing fully 100%, AI generated videos.
Podcasts. Google had this podcast thing where you can just send a transcript, and it would create synthesized two voices of people talk, or even you can send it a text and it would actually analyze the text and then make a podcast of two people discussing it. And it wasn't actually that bad, but it's fascinating that these things are out there. It feels weird though, because we're generating content for the sake of generating content. Like, is it going to be only bots reading those things and watching those things, or is it really people?
I do wonder that, like that. This is one of the things that I wonder. When I see some of I personally, when I sort of sense that it's like just purely generated on YouTube or something, I tend to stop watching. The Notebook LM, which is what you were talking about, that is kind of cool though, where you can basically put up an academic paper and then have it not only read the paper for you, work out what the paper is about, turn it into a podcast, even do other research about it. So if there are terms that are only in that paper or something that's maybe maybe the average listener is not going to know, it can work out, okay, we should define what this term means or explain this term, and then put it into a podcast where people can then just, be going for their morning walk, and rather than having to struggle through an academic paper, they're able just to listen to a podcast about it and sort of get what it's about. I think, things like that are really interesting. I love the whole sort of thing with the language models where you can do the sort of explain it like I'm 5 kind of thing. One of my favorite prompts is explain it like I'm 5, explain it like I'm 15, and explain it like I'm an undergrad, right? And give me 3 explanations of everything. And from that, you can then sort of just skim through it, and you can kind of get, okay, now I understand what relates to what in this paper, or, that kind of thing. And I think that's really helpful if you're trying to learn something really technical that's maybe not in your everyday sort of wheelhouse that you're just used to doing. It's something that like, okay, I would like to kind of know how, WebRTC works or something like that, right? And but I'm not that's not my thing, kind of thing. And I see this a lot for where people are able then to learn new skills. Just doing this, even with my own staff, I get this a lot too, of where I look at what they're doing and I'm like, I know you're not a coder. How did you understand that, right? Oh, well, I asked Gemini, or I asked this LLM, and I kind of got this right. Or they will come to me and ask me okay, do I understand this right? This is what I've sort of pieced together with an LLM, and and more often than not, yeah, they're right. They've got a good understanding. I think that's really cool because I think for a lot of I'm a self-taught developer, right? I didn't go and do a computer science degree or anything like that. And I can remember when I started learning, it was really difficult to find information on why what was OOP, right? Who came up with this? What, these kind of things. And unless especially sort of most of the time I was based in Asia, there weren't necessarily the books in the bookstores that explained all these things. And so it was sort of challenging. I think nowadays, this is where, kids have really got it easy in many ways, that they can basically, maybe that's the wrong way of saying it, that they've got it easy, but they've got this massive advantage where they can just learn things by asking questions. And I think that's that's where these models really sort of shine. It's not that the model should be good at impersonating people to do the kids' homework, something like that. But when a lot of people in the world can't afford to have a private tutor or something, these things can basically be as good as almost any tutor in the world. And I think that's really awesome.
And I think the going away from the physical bit was the part as well. I mean, I remember when I wrote my JavaScript book in 2006, and I went to Hong Kong in 2010. I saw a Chinese version of it, and I'm like, okay, that's cool. And I saw some other JavaScript pocket books, and they were full of weirdly enough, swear words in the variable names and stuff, English swear words. And you're like, how did that get printed? That was really bizarre. But I see with playbooks as well, the amount of times I read things on my phone and I keep touching words to explain them to me if I don't know what that word means or how it's written. And you got into a more of a learning experience with that. And I think that's another, and one of the last bits that I wanted to ask you about. One of the big things that every headline is about right now is how these models are actually starting to emulate or get really close to rationalizing things and thinking themselves. Basically what deep reasoning models is the internal word, but normally they're computers are thinking now for themselves. Are we there? Is it something, or what's going on there? Why would we want to make computers think for themselves rather than just us telling them what to do?
Okay, so it's definitely a thing. It's probably not that they're thinking for themselves. If I explain it, basically what they've kind of realized now is that if you can get these models to, okay, so if you think about it, what are we doing when we're thinking? We're often asking ourselves questions. We're talking it through in our head, that kind of thing, right? And basically what they're trying to do now is get these models to do the same thing. So when you ask the model a question, the sort of new style of thinking models will, and the new Gemini 2.5 is excellent at this. And it's really fascinating to read its thoughts, because what it will do is say, okay, I need to understand what I've just been asked to do. Let me sort of work out what I think it is. And it will state, okay, the user wants to know this. They probably want to know this, something else. A really good example I had this week with this was a meme that was on Twitter of the Dunning-Kruger effect, right? Mm-hmm. And the interesting thing was I've forgotten the words of what it was, but it was something along the lines of you don't know you're in the Dunning-Kruger effect if if you don't know you don't know kind of thing. But it was a whole play on the Fight Club thing, right, from the movie mm-hmm. Fight Club. And so I was curious to see, like, would the model get this, right? The rest of the image was basically a graph that showed, like, right at the start, you're really high on the Dunning-Kruger effect, then you go down a bit in the middle, and then you come back up on the other side, right? And so I uploaded it, I asked it, and sure enough, straight away, it got, it said, oh, okay, they want to know what, maybe they want to know what the Dunning-Kruger effect is. I could explain that. And then it said, oh, but actually these other words kind of look like this, these lines from this movie Fight Club. And that would mean that it's kind of a play on this. So this is like, a meme about this. And then it gave me a really, perfect explanation of how this was a meme that was kind of making fun of, taking something from the movie but applying it to this thing. And I was amazed, that it could actually work out. And the way that it kind of does it is it kind of talks to itself, right? Is it that it states all these things, and then if the way that these models work is it's all just conditional probability, right? So if we're conditioning an output on what's in there, right? If we just take the question and we try to predict the answer, that's one thing. But if we take the question and then we have it talk to itself about that and kind of predict little parts of it, and then that becomes the thing we're conditioning on for the answer, it turns out that works out a lot better. Right? And the interesting thing is that these models, there are different ways that they can train them now with reinforcement learning, and it turns out that it just makes the model better at giving us the kind of answers that we want as humans. And this is like a really interesting sort of part of it. One of the things I've noticed in the Gemini 2.5 model, and this we're literally it's been out 4 or 5 days at this point, is that it's really interesting to see how it thinks, right? When you can so you can actually sort of open up the thinking, or make it so you can read all the thinking, or you can just read the answer. But when you read all the thinking, you're actually almost getting an education in critical thinking for certain questions, right? So it's fascinating to sort of think about okay, all of this, I'm doing it subconsciously. I'm perhaps not even thinking about it. But yes, okay, I probably did this step and this step and this step, as I've gone through that. And it turns out this seems to make the models more intelligent, give better answers out. And it's sort of like the latest and greatest thing that we're seeing with LLMs is these, what they're calling reasoning models, where it can kind of do reasoning about what it's been asked to do first and then produce the product of what it's actually supposed to produce out. Turns out that helps for coding. Turns out that helps for a whole bunch of different tasks.
Because I see with coding models that actually create a use case and create a use test and run it and basically try to execute the code, and then when it doesn't execute, regenerate it. The frustration bit that we had in the past, no, don't offer me that because it was wrong the first 3 times, that it does that internally now as well. In the offerings that we have in the Gemma space, are these general purpose models, or are there also special weight models for different use cases? Are they on offer as well, or do you have to do the filtering yourself?
There are versions of Gemma, the older versions of Gemma, where they actually made a code Gemma, so one specifically for sort of coding. The new 3.0 models are way better at coding than the older code-specific models. So we'll see whether Google makes a Gemma 3, a code version of that in the future. At the moment, it's certainly pretty good. This Gemini 2.5 model is very good for coding. It's very good at sort of being able to look at certain bugs, work things out. And Google's definitely committed to this idea of, okay, they've got, a whole product called Code Assist, which they're trying to work on. I think one of the key things around that is that they want to continually update the training on these so that as new open source packages come out, as people's sort of thoughts change over time, or their stack changes over time, that they're constantly updating that to basically have sort of the latest examples training it on the latest examples, so that when you're doing something, it can probably work out what it is you're doing. The other interesting thing you sort of were getting at before is the whole idea of sort of an agentic kind of thing. And this is one of the things that's becoming really popular, this idea of where it will do something, it will then check its own output, and then it will update, it will try and fix it if it doesn't work. So that, these things where the model will generate the code, it will write a test, it will run the test. If the test doesn't pass, it will then examine, okay, what was wrong with this code? And you're totally right that in the past, the models would just go, oh, no, okay, here's my wonderful solution. And you're like, hang on a minute, that's exactly the same as before, right? And after 5 times of that, you're kind of like, okay, this is not, this is never going to work. The crazy thing with these things, though, is that they don't work until they work, right? If it sounds like kind of stupid, but they don't work. And then when a new version of the models are just getting better and better, and then suddenly they do work. And we're on the cusp now, I kind of feel. So a year ago, I wasn't a big fan of coding with LLMs or coding with AI or anything like that. I just thought like, best it can do is sort of like autocomplete or that kind of thing. Now I'm definitely seeing that change. I'm definitely seeing that with the new coding tools, the latest models, that for anything that's kind of standard code out there, like where there's lots of examples on GitHub or something like that, or just stuff that people do a lot, these models are probably really good at it. The way people are predicting is that sort of 6 months from now, we're probably going to see 80-90% of code be written by these models. I must admit, I kind of resisted that, but I'm now starting to think it could be true.
But yeah, it could be true, but there's a fossilization problem, isn't it? Like the weighting of the models takes time. So newer functionality, newer structures, newer ideas of programming will take time to come in. So we keep repeating tried and true approaches, I guess, but also approaches that might be inefficient, and there's newer ways of doing it. But as developers will never get them on offer or never see the need to actually look them up, there might be a stalling issue with that.
It's definitely something that's interesting. One of the things with the new agentic ways is that they can kind of generate lots of ideas. And they're doing this more for things like drug discovery or something like this, where you generate just a lot of ideas, and then you have some kind of verifier or tester which tests them all to see, okay, which is the most efficient, which is the best way of doing that. And I think we may see, you'll probably end up seeing things like that with coding as well, right? Where it'll sort of like ask you, at the moment, the models tend to go off and just do it, right? I think the next step that we're going to see is where the model has a conversation with you. Says, right, okay, you want to do a Chrome extension. All right, what do you want your Chrome extension to do? And okay, how do you want it to look? And give me a picture of something that you like. And what sort of color scheme do you like? And there's going to be this more interactive kind of conversation about the code. And I think this is where I don't buy into the whole thing of like that, developers and coders are kind of dead and look for a new job kind of thing. I just don't get it at all, because at the end of the day, you need to be able to have the conversation with this thing, and you need to know like how these things work, right? You need to be able to say, right, okay, I want a class that's going to do this and this and this. I want I want to maybe use functional programming, or I want this is the way I want you to do something. And I kind of feel like that's the kind of thing where there's no getting around it. You still have to learn, how these things work to be able to do that. And the model can understand you, right? When you sort of communicate with it in that way, and it can then probably write a lot of that code for you, that saves you a lot of time. But you still need to be able to then go through it and skim it and sort of say, okay, I told you do it all functioning programming, and I've seen 3 classes already, or something like that, right? Of where you can sort of, check for it. And especially when we're in this transition time, I think that's going to be really crucial.
Mm-hmm. I mean, it's always been a skill. I mean, coding, and I gave a talk in 2018 where I said like killing the golden calf of coding, where I say like coding is not the end. It's actually a means to it. And you actually do more by thinking about what you want to code before you code it to actually make something good. I mean, machines are only as good as the questions we ask them. And if you don't have the expertise to actually ask the right question, of course, you're not going to get the right result back. It's interesting that there is an integration into tools. I think in Google's case, it's IDX that they're using internally and is also available publicly, but it hasn't made much of a splash like most of the other code-first editors, AI-first editors. And that always fascinates me when, like, back in the days, it was like, here's your dot file, how to set up your terminal, and here's your theme to be the most effective person in your editor. And now there's like every week people telling me use another editor to be more efficient. I still use my VS Code. I'm happy with it. I wrote part of it, so I want to stick with it. But it's interesting that these integrated environments come with these things built in, and I think that's where a lot of people would start with that conversational bit, because it's just part of the UX of the editor rather than starting with a text box like we used to in the past.
Yeah, I think like most of all the tools, things like Cursor, Windsurf, those sort of things, they're actually just forks of VS Code, right? Like they're literally just a fork of VS Code where they've added in sort of they've got around some of Microsoft's plugin sort of technology and stuff like that, where they wanted to have a bit more control, or some of those things. I do think like those sorts of things, we will see probably a lot of them before it becomes clear that this is the most efficient way to do it. People are still sort of working out, okay, do we have like a chat interface on the side? Do we have an agent interface where it can go off and do a whole bunch of different things? I don't think anyone sort of got that, as it has nailed that yet. You got to look at Cursor though. Cursor is like the fastest company in history to get to 100 million ARR, right? And really, they're a fork of VS Code that they've worked out how to sort of put models into it really well. I think there's one in Europe called Lovable, which is also one of the fastest companies, to hit 10 million in like 2 months or something, right? Like really, the growth of these companies is kind of insane, because at the moment, I think the number one use case for a lot of these models is coding, right? And is this sort of area. My guess is we will see that sort of proliferate through other jobs and other things over time. And then it will just be kind of like taken for granted that, oh yeah, okay, these things are going to go everywhere. But I think like developers are pretty cool at trying new things. Generally, we're not Luddites. We kind of like don't mind, giving something a go and seeing, okay, how could this help me kind of thing. Whereas perhaps other professions, a lot less so.
Well, they're also not normally allowed to change their tool chain every week like we are. So that's the other thing. Like a lot of people have like restrictions that way. So we talked a lot. We can talk more for hours, and I think I would love to have you on our show as well. We do a Wednesday from time to time. So one thing when I want to get started about the Gemma models, like where do I find them? Where do I go? What's the fastest way of getting into it in your case?
So the one of the simplest ways would be to go to AI Studio or just ai.dev. Google, owns the .dev extension, so they've got ai.dev, which links to AI Studio. You can try both the Gemma and the Gemini models there, and from there you can sort of click to where you could try them on Hugging Face if you wanted to download it locally. If you want to run it locally, you've got things like Ollama or LLM Studio. These are sort of well-known tools, or becoming more well-known tools, where people can run these models locally. You can then basically write your code to just ping, Ollama's sort of server, even though it's running on your machine, so that you can basically just interface it with it that way. So they're probably the simplest ways that people can get started.
Excellent. Well, thank you very much, Sam. That was very insightful. We're going to be editing this, releasing it, and then we see if more people get from it. And I can see we're vibing quite well here, not vibe coding, but like there's a lot of balls we can throw to each other. So I think there will be more coming in this one. So thanks for watching, and thanks for seeing Sam. You're available on the YouTubes if people want to see you, right?
Yes. just Google my name on YouTube, and you'll see a bunch of videos about LLMs and stuff.
Or Bing it, or DuckDuckGo it, or whatever you want to do. Like, you will find Sam Witteveen. It's good to have a name like Witteveen, because not many people have it. Like, if it were Jones, it would be harder to get found, right?
Yeah, I guess, there used to be some sort of clothing store in Holland called Witteveen, but I think it's gone out of business. So yes, so like it's reasonably not so common. Unfortunately, I couldn't get Witteveen.com though. Like, that was one I tried. Never, that was out of my reach. But anyway, thank you for having me. It was fun.
Thank you for being here. This was great. So let's see you soon. And that's it for today with Coffee with Developers.
Bye, everyone.